In this lesson, we're going to be solving this problem. This problem is under the projectile motion. Here, the problem statement it reads as follows. If an object is projected at an angle of 50 degrees to the horizontal plane and its actual velocity is 50 meters per second, calculate the maximum height it will reach, the time to reach its maximum height, the horizontal displacement. So here in this problem statement we have the angle, this angle, we have the velocity. So that means we have the angle which is 50 degrees. Then we have the velocity which is 50 meters per second. Let us draw the diagram to illustrate more about this. Then the diagram will be like this here, horizontal. Then this, it is projected from this way like this, then it dropped this, but then the maximum height they are talking about, this one, this is the maximum height from this point here. That's the maximum height they are talking about. Then let us put the points here. Say maybe here it's A, the maximum height it is B, here it is C. This is the object. Say here the velocity, this velocity it is 50 meters per second. It go up. Then here it is 50 degrees. It is like this. Then here we will have the vertical component this side, and here we will have the horizontal component this side. We're looking for this height from A to B, this height. Let's say maybe here the point it is D. We're looking for this height from D to B. Then what we're gonna do here, because here we're dealing with a vertical component, we have to find the velocity for a vertical component. The velocity for vertical component will say VC is equal to, because we're dealing with a vertical component, we'll use sine, we'll use this velocity, then sine 50 degrees. Then this, it's gonna give us the vertical component to be 38.80 meters per second. That the velocity we will use to find this maximum height. Here the formula that we're gonna use, but before we use that formula we have to bear in mind that here the object, when the object is from A here, it goes here in this point at B. While it's on this point on B, the final velocity is 0. Then here when the object it moves from A to B, it's against the gravity. That means the gravity it's negative. Now it's from B to C. Because this, when this object is from B to C, it's not against the gravity on this side. But from A to B, it's against gravity. So the G will be negative. Then let us write that formula that we're gonna use to find this maximum height they are looking for. This maximum height, we'll use one of the equation of motion, which is, we'll say it is, this represent by h is equal to a final velocity squared minus the initial velocity squared divided by 2g. Then here the final velocity, here we said it's 0, then 0 squared. The velocity that we're gonna use here is this velocity. It is 38.30, then you put squared, divide by. Then here, because it's a maximum height from A to B. That means this object was against the gravity. We'll use the negative 9.81 like this. Then here it's gonna give us the maximum height to be 74.8 meters. Gonna give us this. That means the maximum height that it gonna reach, it is 74.8 meters. That's the maximum height the object gonna reach. Then from here they said you must calculate the time to reach its maximum height. That means the time from here, from point A to point B. So here the formula that we're gonna use to find that time, we'll use the one of the equation of motion formula. It is V final is equal to V initial plus GT. We're gonna use this formula. Then because here we're talking about the time it takes from A to B, that means we'll put A to B here in time. Here the gravity, as we said, that when the object from A moving up to B, the gravity is negative. So here we'll use the negative 9.81. Then here on B the final velocity is 0. Then here we'll use this vertical component velocity that we found here. It is 38.30 meters per second. Then let us substitute. We have 0 here in final velocity. Here we've got 38.30. Then plus here we've got negative 9.81. Then the time take from A to B. Then the time it take from A to B, it is negative 38.30 divided by this gravity, negative 9.81. Then it gives us 3.9 seconds. That from A to B it took 3.9 seconds. That means when you want to find the time it takes from A all the way A to B and C, that means you're gonna say, because the time it takes from A to B, it's the same from B to C. That means even here to this, it is 3.9, and this side is 3.9. 3.9. You get the time it takes from A to C. That means you're gonna say, when you want the time it takes from A to C, we'll say 2 times this 3.9, you get 7.8 seconds. Then from here the statement say, let us find the horizontal distance. That means they are looking for this distance from A to C. We will use this formula, which is S is equal to initial times T. This T that we're gonna use is this T, not this one. It's this, the time it takes from A to C. Plus half GT squared. That's the equation we're gonna use. Since we know, because we are dealing with horizontal now, we are finding the horizontal distance. That means G is 0. That means we left with this. S is equal to V initial times A times T. It take A to C. Then we're looking for this distance, horizontal distance. We have to find the velocity for a horizontal component here. A velocity for horizontal component will say the actual velocity here, it is 50. Then we'll use cos because we're dealing with horizontal component. Then our angle, it's 50 degrees. Then here, the horizontal component velocity, it is 32.14 meters per second. That's the horizontal velocity that we're gonna use here. Then the time, this time 7.8, it gives 250.7 meters. That's a horizontal distance. This distance, it's a distance from A to C that they were looking for here, from A to C. That's how you calculate this problem. Got the time to reach its maximum height. The time it was A to B, it was 3.9 seconds. Here, the horizontal distance, it is as A to C is equal to 250.7 meter.